Amplitude modulation, or AM. Amplitude modulation results when a carrier component is added to a DSB signal, adding a carrier component AC cosine 2 pi FCT to the DSB signal given by 3.3 and scaling the message signal gives in which the modulation index, which typically takes on values in the range 0 less than 1 and MNT is scale version of message signal MT. The scaling is applied to ensure that MT MNT is greater than -1 for all mathematically. You know that for less than 1, the condition MT is greater than -1 for all ensures that the envelope of the AM signal defined by 1 plus MNT is negotiative for all. We will understand the importance of this condition when we studied envelope detection in the following section. An AM signal can be demodulated using the same coherent demodulation technique that was used for DSB. However, the use of coherent demodulation negates the advantage of AM. The advantage of AM over DSB is that a very simple technique known as envelope detection or envelope demodulation can be used. An envelope demodulation is implemented as shown in figure 3.3. It can be seen from figure 3.2. So, ayan yung figure. From observation of figure 3.3 that if the envelope of the AM signal goes negative, distortion will result in the demodulated signal, assuming that envelope demodulation is used. The normalized message signal is defined so that this distortion is prevented. The normalized message signal MNT is therefore found by dividing MNT by a positive constant so that the condition MNT is greater than -1 is as justified. This normalizing constant is minimum MT. In many cases, practical interests such as speech or music signals, the maximum and minimum values of message signal are equal. Envelope detection. So, what is an envelope detection? An envelope detection, sometimes called a peak detector, is an electric circuit that takes a relatively high frequency amplitude modulated signal as input and provides an output, which is the demodulated envelope of the original signal. In order for the envelope detection process to operate properly, the RC time constant of the detector shown in figure 3.3a must be chosen carefully. The appropriate value for the time constant is related to the carrier frequency and to the bandwidth of MT. In practice, satisfactory operation requires a carrier frequency of at least 10 times the bandwidth of MT, which is designed W. The cutoff frequency of the RC circuit must lie between FC and W and must be well separated from both. So ito yun, pang separate. All information in the modulator output is contained in sidebands. Thus, the carrier component of 3.10 AC cosine WCT is waste power as far as information transfer is concerned. This fact can be of considerable importance in an environment where power is limited and can completely preclude preclude the use of AM as a modulation technique is power limited applications. The first term in the preceding expression represents the carrier power, and the second term represents the sideband information power. The efficiency of the modulation process is defined as the ratio of the power in the information bearing signal, the sideband power, to the total power in the transmitted signal. If the message signal has symptomatic maximum and minimum values such that minimum MT and maximum MT are equal, when M2 and T is less than 1, it follows that for less than 1, the maximum efficiency is 50% and is achieved for square waves types message signal. If MT is a sine wave, M2 NT equals 1, 2, and the frequency is 33 is to 3% for 1. Note that if we all allow the modulation index to exceed 1, efficiency can exceed 50%, and that EFF 100% as infinity. Values of greater than 1, as we have seen, preclude the use of envelope detection. The modulation carrier and envelope detection outputs for various values of modulation index. So ayan. The modulation trapezoid. Modulation trapezoid. The trapezoid method of measuring amplitude modulation uses scopes X and Y inputs. The modulating signal goes on the X input while the modulated signal drives Y. The audio level is adjusted to produce a usable trapezoid display. The length of the trapezoid's left side shrinks with a rising modulation level. A nice tool for monitoring the modulation index of an AM signal is the modulation trapezoid. If the modulated carrier XC is placed on the vertical input to an oscilloscope and the message signal MT on the horizontal input, the envelope of the modulation trapezoid is produced. The basic form of the modulation trapezoid is illustrated in figure 3.6. So ito yun. Ayan. So, yun lang.